In the quest for longevity and optimal health, few molecules have captured the attention of researchers and health enthusiasts quite like nicotinamide adenine dinucleotide, better known as NAD+. This critical coenzyme, found in every cell of your body, plays an indispensable role in energy production, DNA repair, cellular communication, and the regulation of your body's circadian rhythms. As we age, our NAD+ levels naturally decline, dropping by as much as 50% between youth and middle age, a decrease that many scientists believe contributes significantly to the aging process itself and the development of age-related diseases. The decline in NAD+ levels has been linked to a wide array of health concerns, including reduced energy production in our cellular powerhouses known as mitochondria, impaired DNA repair mechanisms that leave us vulnerable to accumulated genetic damage, decreased activation of proteins called sirtuins that regulate cellular health and longevity, increased susceptibility to metabolic disorders like diabetes and obesity, compromised cardiovascular function, and declining cognitive performance. Given these far-reaching consequences, it's no wonder that boosting NAD+ levels has become a central focus of anti-aging research and a growing area of interest for those seeking to optimize their health span. However, not all NAD+ boosting strategies are created equal. The supplement market is flooded with products making bold claims, but which approaches actually have solid scientific evidence behind them? In this comprehensive guide, we'll explore 5 NAD+ boosters that have demonstrated real effectiveness in clinical research, examining how they work, what the science says, and how you might incorporate them into your own health regimen. Understanding NAD+ and why it matters. Before diving into specific NAD+ boosters, it's important to understand what this molecule actually does in your body and why maintaining adequate levels is so crucial for health and longevity. NAD+ serves as an essential cofactor in hundreds of metabolic reactions throughout your body, acting as a shuttle that transfers electrons between molecules during the process of cellular respiration, which is how your cells extract energy from the food you eat. Beyond its role in basic energy metabolism, NAD+ is required for the function of several protein families that directly influence aging and disease resistance. The sirtuins, a family of 7 proteins in humans, depend entirely on NAD+ to function. These proteins regulate everything from gene expression and DNA repair to inflammation and stress resistance. Another group of enzymes called PARPs, which repair damaged DNA, also consume NAD+ as they work to maintain the integrity of your genetic code. Additionally, NAD+ is necessary for the proper functioning of enzymes involved in circadian rhythm regulation, helping to keep your body's internal clock synchronized with the natural day-night cycle. The problem is that NAD+ levels don't remain constant throughout life. Research has consistently shown that NAD+ concentrations decline progressively with age in multiple tissues, including muscle, liver, brain, and fat tissue. This decline appears to be driven by several factors, including increased activity of NAD+-consuming enzymes, reduced production of NAD+ from its precursor molecules, and increased breakdown of NAD+ bioenzymes that become more active with age. The result is a gradual erosion of cellular function that manifests as many of the hallmarks we associate with aging. The first booster, nicotinamide riboside. Nicotinamide riboside, commonly abbreviated as NR, has emerged as one of the most extensively studied and promising NAD+ precursors available. This naturally occurring compound is found in small amounts in cow's milk, yeast, and some other foods. But the quantities present in dietary sources are generally insufficient to produce significant increases in NAD+ levels, which is why supplementation has become popular. What makes NR particularly effective is its unique metabolic pathway. Once ingested, NR is converted into nicotinamide mononucleotide inside cells, which is then rapidly converted into NAD+. This pathway appears to be highly efficient, bypassing some of the rate-limiting steps that can slow down NAD+ synthesis from other precursors. Multiple human clinical trials have demonstrated that NR supplementation can successfully raise NAD+ levels in blood and various tissues. Research published in scientific journals has shown that NR supplementation in humans is safe and well tolerated, at doses ranging from 250 to 1,000 milligrams per day. Studies have documented increases in NAD+ levels of 25 to 50% in blood cells following several weeks of NR supplementation. More importantly, these increases in NAD+ appear to translate into functional benefits, with research suggesting improvements in markers of metabolic health, enhanced mitochondrial function, and reduced inflammation in certain populations. One particularly intriguing study examined the effects of NR supplementation in middle-aged and older adults with elevated blood pressure. The research found that daily NR supplementation not only increased NAD+ levels, but also reduced blood pressure and improved arterial stiffness, suggesting potential cardiovascular benefits. Other research has explored NR's effects on exercise performance, cognitive function, and metabolic health, with generally positive results, though more extensive long-term studies are still needed. For those considering NR supplementation, typical effective doses range from 250 to 500 milligrams taken once or twice daily. The compound appears to be remarkably safe, with few reported side effects even at higher doses, though some individuals may experience mild digestive upset or facial flushing when first beginning supplementation. The second booster, Nicotinamide Mononucleotide. Nicotinamide Mononucleotide, or NMN, represents another highly effective NAD+ precursor that has garnered substantial scientific attention and commercial interest. NMN sits just one biochemical step away from NAD+ in the synthesis pathway, which theoretically makes it one of the most direct routes to boosting cellular NAD+ levels. Like NR, NMN is found naturally in various foods, including broccoli, cabbage, cucumber, edamame, and avocado, though again in quantities too small to significantly impact NAD+ levels without supplementation. What distinguishes NMN from NR is its slightly different absorption and metabolism. For years, scientists debated whether NMN could be absorbed intact or whether it needed to be converted to NR before entering cells. Recent research suggests that specialized transporters may allow direct NMN uptake in certain tissues, potentially offering advantages in specific contexts. Human clinical trials with NMN have demonstrated its safety and efficacy in raising NAD+ levels. Studies conducted in Japan and other countries have shown that oral NMN supplementation at doses ranging from 250 to 500 milligrams per day can increase blood NAD+ levels and improve various markers of metabolic health. Research has documented improvements in insulin sensitivity, muscle function, and aerobic capacity in middle-aged and older adults taking NMN supplements. One notable study published in a prestigious scientific journal examined the effects of NMN supplementation in postmenopausal women with prediabetes. The research found that 10 weeks of daily NMN supplementation improved muscle insulin sensitivity and insulin signaling, suggesting potential benefits for metabolic health and diabetes prevention. Other studies have reported improvements in walking speed and endurance, enhanced immune function, and better sleep quality in individuals taking NMN. The typical effective dose of NMN appears to be in the range of 250 to 500 milligrams. Taken once daily, preferably in the morning to align with natural circadian rhythms of NAD+ metabolism. Like NR, NMN appears to be very well tolerated, with minimal side effects reported in clinical trials. Some users report increased energy and mental clarity within days of starting supplementation, though more substantial benefits likely require several weeks of consistent use. The third booster, niacin, vitamin B3. While newer NAD+ precursors like NR and NMN have captured recent attention, it's important not to overlook niacin, also known as nicotinic acid or vitamin B3, which has been used for decades as both a nutritional supplement and a prescription medication for managing cholesterol levels. Niacin represents one of the classical pathways for NAD+ synthesis in the body and remains a viable option for boosting NAD+ levels. Niacin is readily converted to NAD+ through a well-established metabolic pathway, and research has confirmed that niacin supplementation can effectively raise NAD+ levels in various tissues. The vitamin is found naturally in many foods including meat, fish, nuts, legumes, and enriched grains, and it's also available as an inexpensive dietary supplement. For decades, high-dose niacin has been prescribed to improve cholesterol profiles, raising HDL, good cholesterol, and lowering LDL, bad cholesterol, and triglycerides. The challenge with niacin as an NAD+ booster lies primarily in its side effect profile, particularly the notorious niacin flush. This temporary but uncomfortable reaction involves redness, warmth, and tingling of the skin, particularly on the face, neck, and chest, caused by niacin triggering the release of prostaglandins that dilate blood vessels. The flush typically begins within 15 to 30 minutes of taking niacin and can last for 30 to 60 minutes. While harmless, many people find it unpleasant enough to discontinue use. However, the flush response tends to diminish with regular use as the body adapts, and strategies exist to minimize this side effect. Taking niacin with food, starting with lower doses and gradually increasing, or taking an aspirin 30 minutes before niacin can all help reduce flushing. Extended-release formulations of niacin produce less flushing than immediate-release versions, though they carry a slightly higher risk of liver-related side effects at high doses. For NAD+ boosting purposes rather than cholesterol management, lower doses of niacin may be effective and better tolerated. Doses in the range of 25 to 100 milligrams daily may provide NAD+ boosting benefits with minimal flushing, though higher doses in the range of 500 to 1,000 milligrams may be necessary for more substantial effects. Anyone considering high-dose niacin supplementation should consult with a healthcare provider, particularly if they have liver disease or are taking medications. The fourth booster: exercise and physical activity. While not a supplement you can take in pill form, regular physical exercise represents one of the most powerful and well-validated approaches to naturally boosting NAD+ levels and enhancing the activity of NAD+ dependent pathways. The relationship between exercise and NAD+ is bidirectional and complex. Exercise increases NAD+ levels and stimulates NAD+ dependent enzymes, while adequate NAD+ levels are necessary for optimal exercise performance and adaptation. Research has consistently demonstrated that both acute exercise sessions and regular exercise training can increase NAD+ levels in muscle tissue and other organs. The mechanisms behind this effect are multifaceted and include increased expression of enzymes involved in NAD+ synthesis, enhanced mitochondrial biogenesis that drives greater demand for NAD+, activation of energy-sensing pathways that upregulate NAD+ production, and improved overall cellular metabolism that maintains NAD+ pools. Studies examining the effects of exercise on NAD+ metabolism have revealed some fascinating findings. Endurance exercise appears particularly effective at boosting NAD+ levels and activating sirtuins, the NAD+ dependent proteins that regulate cellular health and longevity. Research has shown that regular aerobic exercise can increase the activity of SIRT1, the most extensively studied sirtuin, which in turn promotes mitochondrial biogenesis, improves insulin sensitivity, and enhances fat metabolism. Resistance training also appears to positively influence NAD+ metabolism, though through somewhat different mechanisms than endurance exercise. Weight training stimulates muscle growth and repair processes that require NAD+ and activates signaling pathways that enhance NAD+ synthesis. The combination of both aerobic and resistance exercise may provide the most comprehensive benefits for NAD+ metabolism and overall health. The beauty of exercise as an NAD+ booster is that it comes with an enormous array of additional health benefits beyond simply raising NAD+ levels. Regular physical activity improves cardiovascular health, maintains muscle mass and strength, enhances cognitive function, regulates mood, supports immune function, and reduces the risk of virtually every chronic disease. In many ways, exercise may be the single most powerful intervention available for promoting healthy aging and longevity. For NAD+ boosting purposes, the research suggests that moderate to vigorous intensity exercise performed regularly is most effective. This might include activities like brisk walking, jogging, cycling, swimming, or any other form of sustained aerobic exercise performed for 30 to 60 minutes most days of the week. Adding resistance training 2 to 3 times per week provides complementary benefits. The key is consistency and finding activities you enjoy enough to maintain long-term. The fifth booster: caloric restriction and time-restricted eating. The final evidence-based NAD+ booster we'll explore involves not what you consume, but when and how much you eat. Caloric restriction, defined as reducing calorie intake by 20 to 40% without malnutrition, has been shown in numerous studies across many species to extend lifespan and delay age-related diseases. A key mechanism underlying these benefits appears to be the activation of NAD+-dependent sirtuins and other longevity pathways. When you reduce calorie intake or extend the time between meals, your cells experience a mild metabolic stress that triggers adaptive responses designed to enhance survival during periods of food scarcity. One of the most important of these responses is an increase in NAD+ levels and enhanced activity of NAD+-dependent enzymes. This makes biological sense. When energy is scarce, cells need to optimize their use of available resources, and NAD+ plays a central role in energy metabolism. Research has demonstrated that caloric restriction increases NAD+ levels in multiple tissues and activates sirtuins, particularly SIRT1 and SIRT3, which regulate mitochondrial function and cellular stress resistance. These changes are thought to contribute significantly to the life-extending and health-promoting effects of caloric restriction observed in laboratory animals. For most people, sustained caloric restriction of 20 to 40% is neither practical nor sustainable long-term. However, modified approaches like intermittent fasting and time-restricted eating may provide similar benefits with greater feasibility. Time-restricted eating involves limiting your daily eating window to a specific period, typically 8 to 12 hours, and fasting for the remaining hours. This pattern can increase NAD+ levels and activate sirtuins even without reducing total calorie intake substantially. Studies in humans have shown that time-restricted eating can improve metabolic health markers, enhance insulin sensitivity, reduce inflammation, and promote weight loss when needed. While direct measurements of NAD+ levels in response to time-restricted eating in humans are limited, animal studies and mechanistic research strongly suggest that these eating patterns do boost NAD+ and activate longevity pathways. Implementing time-restricted eating is relatively straightforward. A common approach is to limit eating to an 8 to 10-hour window, such as from 10 in the morning to 6 in the evening, and fast for the remaining 14 to 16 hours. It's important to maintain adequate nutrition during the eating window, focusing on whole foods and ensuring sufficient protein, healthy fats, and micronutrients. Some people prefer a 12-hour eating window, which is less restrictive but still provides many benefits. Combining strategies for maximum benefit. One of the most important insights from NAD+ research is that different boosting strategies may work synergistically when combined. For example, taking an NAD+ precursor supplement like NR or NMN while also exercising regularly and practicing time-restricted eating may provide greater benefits than any single intervention alone. The supplements directly provide raw materials for NAD+ synthesis. Exercise stimulates the machinery that uses NAD+ and triggers adaptive responses that enhance NAD+ production, and time-restricted eating optimizes metabolic conditions that favor NAD+ accumulation and utilization. However, it's important to approach NAD+ optimization thoughtfully and gradually. Starting with foundational lifestyle interventions like regular exercise and healthy eating patterns provides a solid base that supports cellular health through multiple mechanisms beyond just NAD+. Supplements can then be added if desired, starting with modest doses and monitoring for both benefits and any potential side effects. As research into NAD+ metabolism and aging continues to advance rapidly, we can expect to gain even deeper insights into optimal strategies for maintaining healthy NAD+ levels throughout life. For now, the 5 evidence-based approaches outlined here offer practical, effective options for anyone seeking to support their cellular energy metabolism, enhance their health span, and potentially slow aspects of the aging process itself. Since you made it this far, please hit like and subscribe to support the channel. Thank you.